Welcome to Sequences and Series Part 3, Introduction to Geometric Series by Martin Tutorials. For today's lesson, believe it or not, I think you can watch it without watching Part 1 and Part 2. I prefer you watch Part 1 and 2, but you don't have to. You have to watch 1 to watch Part 2, but you can get away with watching Part 3. It's going to be uploaded to my two YouTubes, Variety and Fun Math and Martin Tutorials. What we have in front of us is rows of numbers, okay? These are called geometric series. The fact that it's not random, that they all follow a pattern, is what makes them a series. Now, each pattern has something in common, and that's you're always multiplying by the same number. 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. 40 times a half is 20. Times a half, times a half. 1 times minus 3, times minus 3, times minus 3 for each term. Here, the first term might be random with all of them. We start off with 2 times 1, times 1, times 1 equals 2. And here, each term you're multiplying by minus 1. 3 times minus 1 is minus 3. Minus 3 times minus 1 is 3, etc. What each of these series have in common is that it's a pattern of always multiplying by the same between each number. That pattern is called a geometric series. Okay, so here I just made up one at random. 5, 10, 20, 40. That's geometric because we start off with any number and each term we're multiplying by 2. All right? What I didn't mention in the previous lessons, T refers to term number. Term 1 is 5, term 2 is 10, term 3 is 20. The term number is 3. The contents of the term is 20. And T1, another name which I've taught in the previous lessons, A is another way of saying the first term. In this case, A or T1 happens to equal 5, and R is that common ratio we're always multiplying by. Here we're always multiplying by 2. So in this particular geometric series, R equals 2. In this one here, R equals 3 because we're always multiplying by 3. So I rewrote that exact same series I wrote here. I wrote 5, 10, 20, 40, always times 2. And I'm going to write it in another way here. It's 5. That's 5 times 2. That's 5 times 2 times 2, because each time we are multiplying by 2. And another way of writing it is 5. 5 times 2 times 5 times 2 squared, 5 times 2 cubed, because each time it's being multiplied by another 2. And using the letters A for the first term and R for that ratio, I can write it as A, AR squared, AR cubed, etc. Term 1 is A, term 2 is AR, term 3 is AR squared. Like here, term 3 is 5 times 2 to the squared, where A is 5 and R is 2, which gave me 20. And term 4 would therefore be AR cubed. So what we notice, each term is A times R to the n minus 1. Like term 3 would be 3 minus 1 in the exponent. Term 4, 4 minus 1. So there's our formula for a geometric series. Term number n is AR to the n minus 1. So term number 7, plug in the first term, put in what R is, that common ratio we're multiplying by. And if it's term number 7 to the power of 7 minus 1, which is 6. So that's the formula for finding the nth term. And what I'm going to do, I'm going to write that line again. Sn equals A plus AR squared. Now the nth term is AR to the n minus 1. That's what we just said a minute ago. That's term number n. S means the sum of all the terms up to term number n. Like T4 means term number 4. S4 means adding up the first 4 terms. adding up the n terms is adding up a plus AR squared until AR to n minus 1. I'm going to multiply this line by R for a reason. Okay, what I do to the left, I do to the right. I'm actually going to find a formula. So Sn times R, A times R is AR, I write it here. AR times R is AR squared, I write it there. And all the way until AR to n minus 1 times R is AR to the n. Remember, when we multiply, we add the exponents. R means times R to the 1. N minus 1 plus 1 just gives n. Okay? And now we have an equal sign. I subtract each side. Sn minus R times Sn means the total of all the terms minus R times the full totals. A minus 0 is A. AR minus AR is 0. AR squared minus AR squared is 0. All the missing terms give me 0. 0. 0 minus AR to the n is minus AR to the n. So Sn minus R times Sn is the total of all the terms, is A plus 0 plus 0 plus 0 plus 0, all the way until minus AR to the n. I can remove the zeros. Total minus R times total is A minus AR to the n. I can take out that total as a common factor. We're left with 1 minus R. So Sn times 1 minus R. And I can take out A as a common factor into 1 minus R to the n. I can divide each side by 1 minus R. I get Sn, the total of all the terms, is A times 1 minus R to the n over 1 minus R. Or if numerator and denominator are made negative, I can say R to the n minus 1 over R to the n minus 1. Both are correct depending on your teacher or the course. And of course, every course has different terminology. If you're at school, I suggest using the terminology that your teacher uses. That's the formula for adding the terms, whereas that's a formula for finding the nth term. So now that we have our two formulas, here is a question I made up. This is a geometric series, 3 plus 12 plus 48 plus 192 plus ... Each term is multiplied by 4 to get to the next, so it's geometric. First question, what's the 11th term? That's our formula. Tn equals AR to the n minus 1. A is 3, R is 4. So it's 3 times 4 to the 11th term, 11 minus 1, which is 10. 3 times 4 to the 10, we plug in a calculator, 3,145,728. And that's the answer. Next question, add the 11 terms. That's the formula we have for adding up the terms. We're told A is 3, 1 minus R to the n, which is 4 to the 11. R is 4, 11 terms, over 1 minus R, 1 minus 4. We use a calculator. That simplifies to 4,194,303. So the 11th term is 3,145,728, and the first 11 terms add up to 4,194,303. And I think using these formulas is much quicker than writing it out 11 times and then adding them all up. But if we don't make a mistake, we get the same answer. And that's Introduction to a Geometric Series, and thank you for watching.